Right there. All right, so
Like a futon, like a nice copy.
we started off.
Sectional right now would be great.
We started off with the other day going over this Whirlpool VMW washer, which I haven't uploaded that video yet. I'm waiting to go over the whole entire washing machine. That I'm going to make videos that are machine specific. Eventually, future students can watch a video on this whole washer and know what all the parts are, so when they're working on it, they know how to do all kinds of stuff. The one that we were lecturing on was the Whirlpool VMW washer, but before I actually talk about this system here, the drive system, I want to talk about the Whirlpool direct drive washer system. And what I want to do is I want to compare it, because basically this system here on your right has changed to this system. So this is what's been in the washer for the past 20 plus years on the Whirlpool direct drive washer. When I was in school back in the 80s, 1981 is when I started taking to school, the teacher had a washer in there called the Whirlpool direct drive washer, was called the Design 2000 washer. And I always walked by and looked and said, the Design 2000 washer, what the hell is that? Back then, Whirlpool had a belt-driven washer, which had, I think I showed you guys in the last lecture, that big old transmission with what they call a wig-wag, this thing moved back and forth and everything. I'm not going to talk about that. But they changed to the direct drive washer, and this washer's been, it has its issues like any other machine has its issues, but it was very dependable. And it was very easy to service. And it came around, and it's been around for 20 or 30 years, and to be honest with you, Whirlpool probably would not have changed it if it wasn't for the government mandating use less electricity, less water and everything. So in going from here, they redesigned to this, and I'm going to talk about it. I do need the pieces that were on the bottom of this one, the pulley and the plastic parts. Does anybody know where those parts are on this machine? I'm going to pause this for a second. All right, so when I came out this washer, and I think I mentioned about this, this is an actual transmission gear case. On the newer washer, which was the VMW, this may be called a gear case, but it doesn't have any gears in it. It's really not a transmission at all. Okay, I'll get into that in a minute. I want to talk about the functionality of this and how some of the same technology is still used on this one, and a lot of other top-loading washing machines, there are similarities to these components. So let's start off with this Whirlpool direct drive washing machine. Now y'all probably can't read it right here, but there's a stamp on this transmission. And the stamp says neutral gear case, okay? Neutral gear case. When they first came out with this washer and designed it, they had a transmission, but it had no neutral gear. You know, like your car has drive, reverse, and then it has a neutral. Well, the original transmission didn't have a neutral. What made it go one way or the other way, as far as agitation or spin, was the motor reversing direction. And the motor, when it reversed direction, the motor just went one way. It just went clockwise, and when it went clockwise, it was connected with a plastic piece right in here. It's got a plastic piece here. This is part of a coupling. There's another piece that went on the motor with a piece of rubber in the middle. And the motor was mounted right here. So the shaft of the motor connected to the transmission with just two pieces of plastic and rubber. It's called a coupling. And instead of having a belt, like the motor spin a belt turning transmission, the motor was mounted on here. And this was the first, what we call direct drive. Now, a lot of the washers you work on now, you'll find that the motor is attached directly to the agitator or the spinning basket and is a true direct drive washer, but Whirlpool called their washer the direct drive. Now, when they went into agitation, the motor went one direction, and when we went into spin, the motor went the other direction. Back in the day, I used to hook up a little socket right there and hook it to my drill, and I could run it. And you know what? I think let's do that real quick so I can show you guys some of this functionality and explain a little bit about the neutral drain and what's important about it. So let me pause. I think it was recording the whole time too.
No, you're good.
Oh, it's good? Okay. So I hooked up this like as if the motor was connected to it. Now if you watch and I turn one direction, notice how I'm spinning this. Two things are happening. We have this shaft here, and we have this piece here, and I'll explain to you what each one is and what they do. Now if I change direction, and this already spun out, I'm not gonna be able to get it done right. But if I change direction, well, it's not gonna work. I'll rig up a coupling and shoot that in another video. So when the motor goes one way, these two shafts both turn. Notice we got two separate shafts, one inner and one outer, okay? It goes the other way, only one shaft moves, which is the inner. Now on this agitator, or on this transmission, the agitator sits on the center shaft. So let's just take this out like that. So the agitator sits on this shaft. So while the transmission's running, the way the gears are set up, it's going to cause the agitator to go backwards and forwards to create its washing action. This here is called the spin tube and brake assembly. This is what this basket itself, the spinning basket, would connect to. Now this one doesn't connect to that. This is the VMW one. But this basket here is what connects to the outer shaft, this piece here. And when this spins, the basket spins. When this doesn't spin, the basket stays still. And when we want the machine to agitate or wash, we don't want the basket to rotate. We want the basket to stay still. If the machine happens to spin and agitate simultaneously, the clothes will get all wrapped around the agitator. The agitator is this piece here. This agitator would sit on the shaft, and even though it's on that one down here like this, it'll probably even sit on this one a little bit high because the shaft's so long. Yeah, it fits on the same shaft, not even for this transmission here. Okay? So this shaft goes backwards and forwards and creates this washing action. So going back to the neutral drain, when they first designed this washer back in the early 90s and it came out, the machine was agitating. When it stopped, the motor reversed direction. When it reversed direction, it started spinning the basket. Now the basket sits in an outer tub like this. So we call this the tub. Okay, the outer tub. This is what holds the water. This is not a moving part. This part, it may swing with the springs or the shocks assembly, but the basket sits inside here. So when a washing machine fills up, you do see it in the basket, but the washer's actually filling up the tub. And the basket's inside that tub. And then this is the basket that your clothes go in inside of that, and then you got all these holes so that the water in that tub gets in there. So when we go into spin, if I spin this thing right away with a full tub of water, just imagine like when you're stirring a cup of coffee that's full. If you stir it too fast, it splashes over the tub. And that's what they found out when they first designed the washer. People started complaining that when it would spin, it was splashing water onto the floor. So the manufacturer had to redesign the transmission. So the motor's agitating and washing. Now when the motor shifted direction, it actually shifted into neutral. The motor's still running, but the gears in here are not. And the purpose of that is the other side of the motor was connected to the pump. And when you turn the pump one way, it doesn't do anything. But when you turn the pump the other way, it's draining the water. So when the motor reversed, we went into neutral on the transmission, and the pump started pumping the water out. After about 2 to 4 minutes, designed by the timer cycle, the motor would stop draining and then restart again the same direction, and that would engage it into spin, and the whole basket would spin. But that allowed it 2 to 4 minutes to drain. Now some of these machines will drain up to 17 gallons of water per minute. So if they give it 2 minutes to drain, before I went into spin, enough water would leave that washer so that when it spinned, it wouldn't overflow to the side. Okay? So how does this all work? That was the transmission. This transmission will cause this shaft to agitate back and forth for wash, but it causes this shaft to rotate for spin. Now when we do spin, this piece and this piece both spin simultaneously. So we don't want the agitator to stay still and the basket to spin around it. That will wrap clothes around it as well, but we do that for spinning. So we got two parts here on the transmission. This part right here, this part is called a clutch. Now, let's see, we got pliers here? I don't think we have any pliers in the drawer here. Oh, we got two. So, this opens wide enough. I need a regular pair of pliers. Give me a pair of pliers. So this is called a clutch assembly. Just like a car, when you shift gears in a car that's stick shift, you have a clutch that you step on that allows you to shift gears. What does a clutch do? Clutch has two main functions. One function is when you step on it, it separates the transmission from the motor or your engine on your car. Because even at a stoplight, your car the motor's still running. So there's a big plate called a harmonic balancing pulley on the back. No, not harmonic balancing, I don't remember what it's called. But there's a big plate on the back of the motor, and the transmission pushes up against it with springs so that it engages the transmission. But think about this. How fast does your car idle when you're sitting at a light? Even on a
1500.
What?
1,500.
That's a
revolution per minute.
little high. It's
RPM.
about a 900 to 1,000 RPMs. What that means is your engine is rotating 1,000 times per minute. It's pretty fast. When you're racing your car, you go up to 7,000 revolutions per minute. That's really, really fast. But think about it, you're sitting still at a light, your car's rotating the motor 1,000 times per minute, your transmission's just sitting still. If I put it in gear right away and try to go 1,000 revolutions per minute from a dead stop, the gears in my transmission would get all destroyed. So what happens is there's a pressure plate that you press on with your foot, and when you put on it, the spring pushes it away from the engine. The engine's spinning now. You put it in gear, and when you let your foot off the clutch, the pressure plate starts to push onto the engine plate. Now the engine's spinning, but that has pads on it, like brake pads on a car. So it's not supposed to stop it, but it allows it to slip so that your transmission doesn't just lock right into the motor and break everything. So it slips, and that's why your car starts moving forward till eventually the two of them are running at the same speed. That's what a clutch does. So a clutch disengages the transmission, allowing you to shift gears, but then when it re-engages the transmission, it just doesn't engage and go like this. It engages, and while this is spinning really fast, this one's slipping, and then eventually it catches up. You know, people don't know how to drive stick shift. You always smell the burning of the clutch because the engine's going too fast or giving too much gas, and the transmission is just burning. So inside of this rotating disc here, we have a set of clutch pads. That's this piece right here. There's little pads all the way around, and I'll bring it to the camera, and I'll let you guys see it in a minute. But there's little pads all the way around here, and some of them you'll see them as white nylon instead of this like fiber optic disc here. But when this piece here wants to spin, it hits up against this spring there. You see that spring and this plate here? So this is like drum brakes on a car. There's a drum inside the machine, and the spring is pushing them outward right now. So it's like brakes on a car, it doesn't rotate. But when we want it to go into spin, we start rotating this clutch, and it's gonna hit this piece. But the outer disc is gonna slip because it's squeezing the spring in a little bit so it doesn't make perfect contact. Then eventually it catches up to speed. So this will eventually grab the clutch plate. This here will push the brake pads in, and so now it's not braking. When you lift the lid of the washing machine on a direct drive washer, you'll see it stop spinning right away, and that's because these brakes are engaging. Okay, So this clutch engages it. Over a period of time, these pads wear, and the customer complains to you, hey, especially on my heavy load cycles, the clothes are coming out real wet. But when you go there, there's no water in the machine's draining. And it could be that these clutch pads have worn, so if you got a 15, 20-year-old washer, you could replace this. You drop the transmission only, pair of pliers, you pull this out, pop a new one right in. Pay attention to the spring though. There's some different color springs that come in the kit, and that's dependent on whether or not you have a standard washer or a heavy duty washer. Heavy duty washer is usually a bigger tub or everything. You look at the original spring and match it up with the replacement spring, but you just open this up and the spring comes right out. Okay, so I could just put the spring right in. No special tools needed or whatever. Except you can't do it while you're holding the brake assembly. Now, what's so important about this? What do I need to know? How do I work on it and everything else? I'm not gonna bother to put this together. This drives the clutch, which releases the brake and allows the basket to spin. The basket is attached to the top of this shaft. The agitator's attached to this shaft. So the basket and the agitator have two separate shafts. They're independent. They do drive together when they spin, and the agitator sits on here. Now on the bottom of your washing machine, there's a gasket. That gasket's mounted on here, and that gasket goes through this opening on the bottom of your tub. So this gasket right here seals this opening here to keep water from running out the bottom of your washer. But if this plate is mounted on here like this, mounted on there like this, you could see water dripping off the top of this plate. Well, let me get this out. The direct drive washer has a seal that goes around here, but it's still attached to the tub. That keeps water from coming out here. But what if water got here in the top of this shaft? Could water leak down in between these two metal shafts? Yes. That there is a seal on the top of this shaft that could be leaking water here. So if you go to a machine and you see water dripping off my transmission, you might think it's a tub seal or a cracked tub, where it could be this. Now, the way the agitator is designed and the way the agitator sits on these washing machines is really, really neat what they did. If you see this part here, there's no holes. You see all the other holes that are around this agitator here? Okay, why do you think it's solid here? What would happen if it's in water and it's sitting like that? As it filled up with water, what would happen? It won't float because it's bolted down, but it would trap water. If I took a cup and put it in a sink filled with water, turn it upside down, that cup would trap water in there, right? Well, the agitators in these washing machines are meant to trap air in here because they don't want air to get around the seals in here, especially the water to get this high up. So even though the shaft's this long, we don't want the water to get up here. Look how short this shaft is. So when this agitator's mounted on this machine, everything from here up, which is where, let's say about this high up, everything from here up should not get any water. So even though we have a seal here to seal this mechanism to the tank, there are seals in here so that if water was ever to get this high, water wouldn't drip down the center shaft here. Okay? That's important to know about where the water could be leaking from if it's leaking from the center. So on a direct drive transmission, two separate shafts, the motor only goes continuously in one direction or continuously in the other direction. Now let's get into the VMW washer and what did they do differently. The VMW washer, this might be called a gear kit case or whatever. If you guys look in there, and I'll see if I can get it in the camera first. There's really no gears inside of there. There's something that looks like a gear, but if you look in the openings here, you can't really see any gears in there. You see something looks like a gear, but if you look, there's really no gears inside of there. It's just walk around, show you guys that. If you look inside the holes, you can't see any gears in there at all.
So is this a split?
Well, no, actually, this whole assembly is just two shafts, and the way this is designed has two bearings, an upper bearing and a lower bearing. Okay? The upper bearing and the lower bearing just to hold that shaft from bending over, just keeping it straight. That's all this is. Everything for agitation and for spin are directly off of the motor and nothing to do with the gear case or transmission anymore. Now they do have these pieces, and I talked a little bit about them before, is that this one pulley, when attached, only attaches to the center shaft. Remember, we have two separate shafts here, an inner and an outer. This one only connects to the inner shaft, and if you look when I rotate it, what's moving? Can't see it?
Is it the center? That center looks like
Just
it's
the
moving
center
something.
one. If I go backwards and forwards, it's washing. Now if I take the agitator, and I'm only gonna put the top half, this bottom half on here. If I put it on there, this agitator is only mounted. It ain't going nowhere. It's only mounted there, so now, but I'm holding the outer shaft in my hand, it's not turning the outer shaft. So that when the washer agitates on this one, the motor goes one way and stops, it goes the other way and stops. So the actual back and forth washing action is controlled by making the motor run one way, then stop, then make the motor reverse and go stop. And that's agitation. Where this one, the motor goes one way and the transmission causes the back and forth washing action. Now the spin basket is mounted to the outer shaft, just like the direct drive washer. On the direct drive washer, we have something called a drive block. It's a bell-shaped piece. Some of them are a little more curved, but Whirlpool's use these, and some of these other manufacturers have something similar. If we look on this shaft here, and I'll go to the phone first. On this shaft here, there's two tabs on the top of it. These are very important. If you look, there's two tabs up here. If you look at the notches on the drive block, that's what lines them up. The two notches there. And I'll leave this stuff out so you guys can look at these parts up close. These two ears and these two holes. See that? The two tabs and the two holes?
Mm-hmm.
So when you mount this onto the basket, you're gonna put this on, then you're gonna put this piece on, and you're gonna line it up with those two notches. I've had people mount it on top of here, but not all the way down. It's not lined in the notches, and then what'll happen is it'll wear and break these off, and now we gotta place this whole assembly. Okay, so you wanna make sure it's down and locked in place, and by locking it in place, the actual basket that holds the clothes sits on here, and as you can see, the transmission and this can move independently. So the basket sits on here, and then on top of this, we have something called a spanner nut. So the basket sits on here, and then this screws on it on the top, and this is what holds the basket to the outer shaft. So we can spin, and the agitator would be independent. And we can agitate separate from the basket. So to take this out, you have to use a special wrench called a spanner wrench. You know, in England, a wrench is a spanner, so calling it a spanner wrench is redundant, you know, like jumbo shrimp and stuff, you know, you don't need to say it that way. But anyways, this spanner wrench, this is one of a universal kit you could buy online, that this one will do 3 different washers. It'll do the real old GE, it'll do the real old Whirlpool, the new direct drive Whirlpool, and it'll also do the Maytag washer, which the Maytag washer uses the 4 tabs here. But this thing here lines up, and this, with a hammer, you'd hit it and you'd unscrew this. Once you take this off, the basket would come off. Then I use this tool, because when it's old, it's hard to get off, and I hit it up. from inside the washer. I use this tool to knock it off. Because sometimes it's hard to get it up off there after it's been there for 20, 30 years. Okay? You take this nut off, you take the basket off, and then you can knock this piece off. Drive block, spanner nut. Okay? That's for that. Now on this machine, we have two separate shafts. I showed you that the pulley, if I rotate it, only the outer shaft is going backwards and forwards. But what if I wanted to spin? Well, they added these other pieces in here. These other pieces came out in, say, middle to late 80s. Only older guys like me who have been with companies long enough know that they came out with this washer for Whirlpool. It was made in Mexico. It was called the World Washer. It was the cheapest washer I've ever seen. Not only was it so cheap, but you know the top, not the lid, but the top of the washer, most of them are metal. And back in the day, these washers were porcelain painted. They weren't just metal with spray paint. They were porcelain that could chip.
Yeah.
They were better against rust and corrosion. Then they went to painted. When they made the World Washer, that whole top was made out of plastic. Okay, but they had a splutch, where you mentioned the word splutch, where they had this piece here mounted onto the mounted onto this gear case, or whatever you want to call it, and there was a shifting mechanism that shifted this up and down. And when it shifted it up, it would lock in, and these two pulleys would be locked together. And that's how the machine would spin. So how did they go up and down? Well, there was a shifting mechanism that would bring this down and bring this up inside the washer. And that's what the actuator or the shifter did. The actuator shifter pushed this piece up, and when it engaged with this main pulley, the washing machine spun. And when it went down, the washing machine would agitate. So when we spin, both pulleys would turn. Now if you look, if I'm connected here with this pulley, you can see I can turn the whole pulley versus the other pulley, and I'll show you guys that too. So if I go in here first to the computer, if I have just the outer one connected to this plastic shaft here, I'm turning both, but if I wanted, I could hold this and still turn the outer one. I could hold this and turn the outer one separate. That's this shaft inside, which is controlled by this one, like that. I put this on backwards. When it goes like this, and these two are locked together, both of them spin, like that. Both of them spin as a single piece. So I can, and I'll show you guys together, I can lift that piece up, and then if you see, I'm just doing the agitator. When I drop it down, I'm doing both. See that? So if you look here, when this piece is away from the pulley, I'm just moving the upper shaft and it's agitating. When I want to spin, I drop it down and engage, and then both of them move, and you can't hold either one still. So if you see that here, when this is engaged, I'm just agitating. When I drop it down, I'm spinning.
So the thing that shifts that white piece, that's the splutch, or the splutch, right, or the shifter?
Well, the whole thing is a splutch assembly. It's the plastic clutch.
Okay. Yeah.
Okay. What was missing from here, and I don't know where it is, was that there was a lever, and that lever is what slid it up.
That
and
arm,
down.
that curved arm, right? That curved arm piece thing.
It's not in the box here, so I hope you didn't notice it.
You had it in your hand the other day or something.
Not from here.
Oh, okay.
But well, that's the lid switch. Where's the actuator? Here. Oh, here it is, right there. So this is the piece right here. If you see, it's like cut at a slight angle, and this piece went inside here like this, and there are pieces in there. And I want you guys to actually like look at it. But if I got it like this, I'm all the way up. But if I turn the piece, it drops down. If I go the other way, it goes up. Now what's happening is there's a spring underneath that's helping force it up. We cannot shift gears just like a car when the motor's running. So the washing machine has to stop when the shifting mechanism is doing this, going up and down. Now when it goes up, that's when it's engaging with this pulley. And we need to make sure that those two are engaged. They're plastic. So if the motor starts to run before they totally engage, what's gonna happen to those plastic teeth? Then destroy them. So now you go to the customer's house, and it says, hey, my washer's not spinning. And you say, oh, I know that's why it's not spinning. These teeth are all chewed up and it's not engaging. But then you have to stop and think, say, wait a minute, what chewed it up? Did the customer super overload the machine and cause it to strip these parts? Or did the shifter not work? So here we have this shifter. And this piece engages to this part here, which is what's shifting that up and down. So they move this piece back and forth by this little motor here, and that's what shifts it up and down to engage and disengage the spin. Agitation, we don't care. It's always connected to the agitation shaft. Motor runs, that shaft's gonna move in spin or agitate. But in spin, we have to make sure the two of them engage. So this thing has a couple of parts. There's a little switch in here that when we engage in one cycle or the other, that's how the washer knows, hey, it's successfully engaged those two pieces or not. Now the motor can run. But then we have this other little piece here, which is like a little infrared beam. And that infrared beam is telling the machine, hey, the motor's not running, you can engage. If it sees the motor running, it won't let the actuator engage it in the cycle. Now if you look right here, and let me get it on camera too, part of this black disc right here has little windows. So when it rotates, the window allows the light to pass through and it pulses, and based on the pulse it knows whether it's rotating or not, and as well as how fast it's rotating. So if we look here, you can see this piece here rotating here, and this piece would sit over just like that, and these two would be going over that, and they would tell the board, hey, this is how fast it's running. So this piece would sit on there like that, so that little black piece right in there goes all the way around, so when it rotates, if you look at them closer before I put them back together, you can see how these two are over top of that black ring there, and that's how it knows how it rotates. So we have a couple of things we have to look out for. We'll start over. Is like we could have shaft seal leaks. Don't happen that often, because if the water got in here, that means water got up your agitator. Okay? Now, the bolts that hold the agitator down are like this one right here. And what's this on the bottom of my bolt?
Is that a rubber washer?
It's a rubber washer. Okay? Little piece of rubber. Why do you think they have a piece of rubber in there? So it's
I forgot where you just put it. Yeah. Never mind.
No, it goes on top of the agitator. This piece here.
Oh yeah, in the center of the agitator.
So this goes down inside the agitator, and it holds the agitator down to here.
Mm-hmm.
But why do we have a piece of rubber in there?
Mm-hmm.
To keep water from going down? No.
No.
To keep air from leaking out. If someone takes an agitator off for service and puts the agitator back on, and this gasket's not here, when the machine fills up, remember I said you got a cup upside down to water, it holds air and keeps water out of this compartment.
Yeah.
But if this seal loses its integrity, it allows air to get up in here, and now we got the possibility of having water leaks in our machine. Okay, so this machine as well as this machine, this bolt might even fit on this transmission, even though it's not for it. Look at that, it fits right on it. Listen, Whirlpool, when they went from one design to another design, a lot of the things are pretty much the same. I showed you that, the agitator fit right onto the same shaft. They didn't change the size or diameter of the shaft. There was no need to redesign that. But the reason why we went from this washer to this washer was just two advantages. One advantage was this machine filled up with less water and designed to run off of less water, so we met government requirements for more energy efficiency. But this was a lot cheaper to make than this, because you have a bunch of gears inside of this thing that make this whole assembly up, and it's a complicated mess inside of there. Let me show you what that looks like inside. I'm gonna open up that book for that washer. I think it's, 3 is the old belt drive washer. And then 4, I think, is, 3B is the direct drive. Okay. I want you guys to see the gearing.
Great.
I'm having problems with this computer, guys. I don't know what's going on here, but I'm having major problems here with this washer. Not this washer, but this. I need to close this and reopen it up. I can't close that. Great. I can't get to my book now. I'll have to show you guys that later. The computer just has an error and I can't even get out of that without restarting the computer. So inside this transmission we have several gears. I don't want you to open up these transmissions that if you open them that they'll tend to leak, but this transmission here has a little tiny breather hole on the top there. So when you're working on the washer, changing a pump or the motor, you can do it with the machine standing up. Sometimes technicians want to lay it down, especially take transmission out. If I lay it on its side, oil will leak out of that hole. That hole is to prevent pressure from building up and allow the heat to escape from the transmission oil in here. This has no oil. This has no gearing mechanism. The only gearing mechanism is this plastic pieces. And the World Washer had the same one. I'd show you guys the World Washer book too if I could get my computer working right. But the drive systems, they do the same thing, spinning and agitating, but they migrated from this to this. This is a Whirlpool VMW washer, but Whirlpool bought Maytag and a Mana. Back in the day, people would go and say, oh, the Mana washer was the best thing, and back then they were really good quality machines. The old Whirlpools were really, really good too. But when Whirlpool bought them, Whirlpool made Maytag and Admiral and Magic Chef and Whirlpool all the same internal system. The only thing different was the control panel just looked a little bit different, had the same, had their name on it, but if you opened up the machine, they're all identical inside. So people now, they're saying, oh, I'm gonna buy a Maytag, the Maytag dependable. You know, Maytag used to have a quality that people say Maytag never breaks down. You know, but the new Maytag is the same as the new Whirlpool. And they have a few different versions of this. The one version has the old pancake motor, like a ceiling fan motor that LG and Samsung made, and they have it on the bottom of this washer. GE has it on their washing machines too. And agitation and spin is done the same way. There's a shifting mechanism that will engage or disengage the spin basket for doing that. So what I'm going to do is I'm going to go through all the drive systems here in these lectures, and then I'm going to use those videos to go with those machines. Any questions on this stuff here? No? I wanted you guys to take a minute and just to take a look at them and get a little closer idea of how parts function and everything else. But then I want to get this thing back together again. So I just wanted to talk about the drive system today. So a lot of people don't know when they go into washer spin, how does it actually engage into washer spin? Okay? If you don't have any questions, if I create a test next week, y'all gonna pass it, right?
Today, right now.
Today, no, I just went over the information. We'll see how much you retain next week. Maybe this weekend I'll put the videos online, but they'll be in the members section, okay? I'll let you guys know. But if you don't have no questions, I know it was a little bit shorter.